Notre Dame is the perfect place for nanoscience research, and it's a highly attractive school, primarily because of the people, the facilities, and the infrastructure. So we have over 20 core facilities, including the Notre Dame Nanofabrication facility, the integrated imaging facility, the materials characterization facility, just an amazing array of capabilities that support nanoscience. So our Center for Nanoscience and Technology actually has over 70 faculty affiliated with it, and they come from both the College of Science and Engineering, 8 different departments, everything from physics, chemistry, biochemistry, biomolecular engineering, chemical engineering, electrical engineering. And the exciting element of it is that we have collaborative discussions and meetings regularly where we promote multidisciplinary research.
So we work with several other teams in developing nanosensors for detecting bacteria, virus, or even host microRNAs for cancer screening. So these are, by definition, interdisciplinary research and will require the latest nanotechnology.
So we utilize a lot the cleanroom facility and the Nanofab, which is a state-of-the-art cleanroom facility equipped with all kinds of cool tools that we use in our research every day. In addition, we have a BioIndenter, nano BioIndenter, that allows us to measure contractile forces of the heart muscle cells, which are at nanoscales. They exert nanonewton scale forces, and we can use these nanoprobes to measure these contractile forces to decide the maturity of our cells is good or not.
The two things that are very exciting for us in research is developing the next generation hardware to support intermittent computing. When the computer comes alive, when power is available, and it completely shuts itself down without losing information when power is not available. The other thing we are excited about is neuromorphic processing. This hardware and computing architecture will enable artificial hardware to behave more like how human brain can analyze, recognize, and classify objects in a very energy efficient way.
We are interested in controlling and manipulating ultra-small quantities of matter, anything from a single molecule up to maybe a few million molecules. Now, in our hands, what we'd like to be able to do is to build nanoscale architectures that allow us to control the properties of electromagnetic radiation on that scale, and then couple that to the molecules that we're interested in studying. And in particular, we're interested in electron transfer reactions. These are reactions, as the name implies, in which electrons are moved into or out of molecules, and they underlie much of modern technology as well as the chemistry of life.
Every core that we have is available to industry players. So we have an open structure, an open model by which our faculty can collaborate with industry players and ideally bring them in to take advantage of not only our facilities, but our researchers who have just a phenomenal breadth of capabilities.
In the industry, we learn very valuable lessons on how to put focus into your research so that you can transition the research as quickly as possible to successful product launch. But at the end of the day, since we are an applied research group, we still have to have that sense of urgency. We still have to do certain level of benchmarking with respect to state-of-the-art technology to see that your inventions and your research breakthroughs are ultimately going to advance the state-of-the-art. So this allows me to introduce my very successful students to that industrial network that I cultivated, and that makes them easy to find jobs once they complete their degrees.
The university has been very supportive. They've provided help with actually attracting investors and also bringing in CEOs for the startups can launch companies here in South Bend and help us commercialize the product.
Here at the Idea Center, we have commercialization space where people can come and work. We have maker space and prototyping space where people can come and try out their ideas and make sure that they're going to work. We have resources and processes that we're putting in place where people can come and learn how to connect with clients, with customers, with entrepreneurs, and with funders, those that might actually provide the resources for their opportunity. Which allows Notre Dame to attract world-class faculty and world-class students, generates world-class ideas, and then brings in the right funding and the right resources and connects that back to its alumni base and to its community base. So commercialization from a mission standpoint in the university becomes a very important connecting factor on all of these different people and brings them all together and helps them all provide value in that process.
We have an administration that's focused on investing on the enablement required to succeed. They've put in place the centers and the institutes that basically provide the framework under which our faculty researchers can succeed. The breadth of it is just astounding. And from my perspective, it's exciting because every day it provides an opportunity for new collaborations, new ways of being able to interact with people to come up with innovative ideas and intellectual property that can really make an impact for good in the world.